Hi, I'm Mr. Evans, and today we're going to continue our talk on motion by covering motion graphs. In particular, we're going to be working with displacement versus time. So to begin our talk on displacement versus time, I've drawn a graph with several different types of slopes, just so we can practice identifying, what different trends look like. And so I'm going to work through A through G on here, and hopefully you can follow along. So we're going to begin with A, all the way on the left side of the screen, and you can see that there is a slope up. Okay, and I'm going to trace it through the blue as we continue. And so displacement is on the y-axis and time is on the x-axis. So as we continue, time has passed. And so on the part of A, that means this person has gotten further away. And so a straight line going up, as you can see in A, means some kind of constant velocity walking away from the initial spot. Next you have B, and it's a flat line. So any flat line in distance or displacement versus a time graph is going to be no motion. Okay, so if this person was, let's say this was 15 meters away, and they were 15 meters away here, and now they're still 15 meters away, they haven't moved. And so at point B, a flat line, no motion. Now you have C, where the object, the slope is down, and what that means is the object is coming back towards the initial spot. And so your initial spot's 0, they ended up being 15 meters away, and let's say now they're only 5. Well, then that person must have came back from the way that they were leaving. Okay, next we have D. That's just another flat line, and so again that means no motion. The person has stopped moving. E, you're going to see it starts getting trickier. This is a sloped line. Okay, and in a displacement versus time graph, a slope line represents, some form of acceleration. So in this case, the slope becomes more steep over time, meaning the slope's increasing, which would mean the object is, speeding up. And so its velocity is increasing. F, again, another flat line. I'm basically just putting flat lines between things just to show where it starts and stops. But again, that would mean no motion. And then G shows a drastic slope, and then the slope levels off, meaning the person's doing the opposite. They're starting off at a high velocity, and they're going to a slower velocity, meaning they're, having a negative acceleration or decelerating. Okay, so now I've drawn a little bit more basic graph, mostly just to simplify, but also to give us some room to work. And now we're going to take this a step further. So we know what these slope means. And, again, if I were to analyze them, we have slope A here. And, that's a straight line, or what's supposed to be a straight line, up. And so that would mean, some type of constant velocity away from us. We have B. And a flat line in these distance versus displacement graphs means no motion. I really want to point out that I'm emphasizing that zero slope means no motion, and displacement versus time, because that's not the case for all graphs, which you'll see in my next video, which covers velocity versus time. But for now, it means no motion, and then we have a negative slope here, and that means some kind of constant velocity again, because it's a straight line back towards the original point. Okay, and so now we're going to use these points to do some math. And so if we can remember our velocity equation, and I'll write it up above the graph, velocity equals change in distance or displacement over change in time. Okay, so let's solve a couple of these. Let's solve what the average velocity was for the line of A, which would mean from the start of our graph to this point over here from where A and B are. Okay, so what was the average speed of the person or object that was moving away from the point of origin? And so your distance there will be, your final distance was, if you draw a line over, was 25, because it's between 20 and 30, and your initial was 0. Over change in time. So your time now is 15 seconds, and your initial time was 0, because that's where we started. And so what you end up with is 25 over 15 equals velocity. And so your average velocity is 1.67 meters a second. And you can do this throughout. So for B, you should be able to solve for it and get 0. So if you wanted to check yourself, you could pause this video and do B real quick and make sure you get 0. If not, I'm going to go ahead and move on to C. And so to do that, I'm just going to go ahead and erase our math over here for A. And now let's go ahead and work on C. And I'll pick a different color so we can tell the difference. We'll do purple. And so now for C, again, we need a change in distance or displacement. And so, let's look at, we have where we started. We started at 25, and this time we are ending at 0. Okay, so again, you're going to have 25 minus 0. Now this time the time might be trickier because the time will not start at 0. So you just do your final time first. Final time is right here, and so that's 50 seconds, and so your final time is 50 seconds. However, your initial time has to be where our spot is here, and so you go down, and our initial time is 30. So then do the math, and you end up with 25 over 20, which equals velocity. And so 1.25 meters per second would be our average velocity for that time. And that makes sense. We covered the same amount as we did at point A, but it took us 5 more seconds, meaning it was done a little bit slower. So hopefully that helps with your displacement versus time and a brief intro on how to use those graphs to do some math. Our next video is going to move on to the velocity versus time graphs, which I feel like are slightly more difficult.